Welcome everybody to class. Let's begin with our voting and apportionment review. Now I'll give everybody a moment to attempt this problem on their own, and then we will discuss its solution. So which of the following would be considered the plurality winner? Now we know plurality is just who got the most first place votes. So for this problem, we only care about the first two rows. And I'm just going to off to the side transcribe how many first place votes each candidate got. We see the first group of 3 voted for A, so they get 3 votes. The next 5 people voted for B. The next 6 people voted for D. The next 2 people voted for C. And then do we see these 4 people also voted for A? So A has a total of 7 votes. So you consider which is the highest number? 7, 5, 2, 6. I guess we'd say E got 0 first place votes. And do y'all agree with A having the highest number? So A is the plurality winner here. Now next up, let's think about which candidate is the majority winner. Remember, for majority, as you're working this problem, first find the total number of votes across any candidate, figure out what is 50% of that, and then see, do any of the first place choices get more than 50% of the vote? Do y'all agree that there were 20 votes in total? So next, to find 50%, you can always just take the total number and divide it by 2. Or I could do 0.5, the decimal version of 50%, times 20. When I do that, I get 10. So if a candidate got 10 votes, they get exactly 50%. But to be a majority winner, you need to be over. So do we agree we need 11 votes or more votes for the majority? So we now know the cutoff. So let's determine, do any of the first place vote candidates get 11 or more? So we can look and see, but if we want just to make sure we don't miss anything, we could also just write it down quickly. A has 5, B has 3, D has 4, C has 2, and then A has another 6, E has 0. So A has 11, which is right at the cutoff. So we'd say A would be the majority winner. How do we feel about those two problems? Any questions? Okay, so we'd circle A wins the majority. Now next up is the border method. Let's get started so that we're all on the same page, and then I'll give you guys time to attempt it on your own. Remember, the Borden method distributes points based on how high in the ranking you place the value. So a good first step for the Borden method is to figure out how many points should you give first, second, third, fourth, fifth place. It all depends on how many candidates there are and how many rankings we have. So since we've got 5 choices, we know that the last place isn't really a choice. It's just you had to put something last. So we don't really count that, which is why we give 5th place 0 points. And then to know how you give the rest points, every time you go up a category, you just give another point. So 4th place gets 0 plus 1, 1 point. Going up a category, we get another point. So we get 1 plus 1 is 2 points. Continue that pattern. 2 plus 1 is 3 points. Plus 1, 4 points. And you know you've done it correct if the first place number of votes is 1 less than the number of candidates. 5 minus 1 is 4. Then remember, for Borden method, you say 3 people wanted A as a first place. So those 3 voters, their vote is weighted by 4. So we say 3 times 4, that contributes 12 points to A. And you fill in the whole table and then add up all the separate categories. So we'll give time for people to attempt this on their own. once we've calculated the total points per voter category and candidate, we need to add them all together carefully. And as we're adding them, we can maybe color code if we have some highlighters written on our paper, or as soon as you tally something. So for instance, I'm going to just write out my list. A, B, C, D, E. However you do this, just make sure you're doing it in an organized way so that you're not missing or double counting. So once I tally A gets 12, I'm going to put a check mark so that I know I've calculated this spot. And we can just continue with some such pattern. B gets 20. D gets 24. C gets 8. A gets 16. D gets 9. Plus 15. B gets 18. A gets 6. D gets 12. E gets 6. A gets 10 and 12. And B gets 4 and 8. Do you all agree? Do this match y'all's calculations? A had 56 votes, B had 53, C had 17, D had 62, E had 12. Okay, so if that's the case, highest number of votes wins. So we see in our case, D is the border winner. So D actually had less first place votes. Notice it only had 6 first place votes versus A, which had 7. But D was very popular as a second place, and A was not so popular, so it eventually overcame that. So now let's do this problem that we have on the screen using the Hare method for voting. As a reminder, so that we're setting out in the right way, remember Hare method has it where you first see, does anybody just outright win the majority? If so, they're the winner. If not, eliminate the lowest ranking candidate and give their vote tally to their second ranking candidate. And then just keep rerunning that where you see if anybody wins the majority. If not, get rid of the lowest ranking candidate and redistribute their votes. So we'd find that the total number of votes by adding all the categories together is 20. 50% of that is 10, but to be a majority winner, you need to have more than 50%. So that leaves us with 11 or more votes would secure the majority winning. Now let's see if just our first place choices, if anybody gets the majority, because if they do, they're the hair winner automatically. So it looks like A gets 7 votes, B gets 5, C gets 2, E gets 0, and D gets 6. Now, none of these win the majority. So what we would do in the hair method is we'd say, okay, we're going to get rid of the lowest ranking candidate. But whenever we get rid of E, does that redistribute any of the votes? Not in this particular case, because E was not in the first place. So we actually have to get rid of the next lowest ranking candidate, because when we end this step, we have to redistribute one of the categories. So we got rid of E first, but it made no change. So this is a rare occurrence, but now we need to get rid of the next lowest, which is C. So we're not going to just get rid of these voters altogether. Okay, they're still going to have a say in the election, but their first place choice is definitely not going to win. So they already said, if I can't have C, then I want my vote to be counted to A. So now in round 2, A will have gained another 2 votes. Does that make sense to everybody? So we run round 2. The only candidates left are A, B, and D. Now we know that A picked up 2 votes, so they went from 7 to 9. Does it make sense to everybody that B and D didn't change their vote tallies at all? Because the only change affected A. Now you ask yourself, do any of these meet the majority threshold, 11 or more? No, highest is 9, right? So we know that we have to, if nobody wins the majority, you get rid of the lowest ranking of the remaining candidates. So do we agree in this case, we're going to get rid of B? Okay, so we're going to find them in the table. These 5 people wanted B as their first place choice. But they said if they can't have B, they want A. So now A will go from 9 votes to adding these 5 to 14. And so in round 3, it will win the majority. So there was only A and D. We know the only change increased A's votes, so D still had 6, but A had 3 plus 5 plus 2 plus 4, which would be 14 votes, and it surpassed the majority cutoff now. So we'd say A is the winner. Any questions here about our hair method?
Well, it's not about the hair.
Yeah.
I saw where it said the exam was going to start Saturday.
Oh. Now for this next problem, if y'all would think about which candidate wins a majority, answer that question. And then when you've done that, run a Board election calculation here as well. And then record who would win in a majority election, who would win in a Board election. So we see that there are 11 or more votes needed for a majority, and B does secure 11 first place votes. Now, as we go through the border method, we know that last place really doesn't count as a preference. It's just where you had to put the last ranking candidate. So we know it gets 0 points. It shouldn't be counted towards anything. And as we increase through the candidates, you add 1 point. So third place gets 1 point. Second place gets 2 points. First place gets 3 points. And we can verify that this is correct because there's 4 candidates, A, B, C, D, E. So first place should always have 1 less points than there are candidates. So 4 minus 1 is indeed 3. Now I'm going to distribute the points. These 11 voters get their votes weighted by 3, so it's 33 points for B. These 5 voters get 3 points for their votes, so that's 15 for C. And then multiplying by 1 is just the number itself. So 11 times 1 is 11, 5 times 1 is 5, 2 times 1 is 2, 2 times 1 is 2. So now I'm just going to carefully make sure I give the right points to each category, tally them up, and then the largest number will win. So B gets 33 points, C gets 15, A gets 6, D gets 6, C gets 22, A gets 10, C gets 4, plus another 4, A gets 11, D gets 5, and then B gets 2 and 2. Do I agree with these values? A would end up with 27, B is 37, C is 45, D is 11. So let's see. So with this in mind, we can see the highest total number of votes was C. So we would call C the border method winner. And what we notice here is you'll see it's the same voting results, but based on which election method we use to calculate the winner, we'd get a different answer. So same results, but if you did majority, B wins. But if you do the same results with the border method, C wins. So this brings us to our next question. Does using the border method in this election violate the majority criterion? So in our notes, we said the majority criterion is the idea that if anybody wins a majority of first place votes, they should be the winner no matter how you calculate the election. So in this case, do we see that though B won the first place number of votes in the majority, it's not the border method winner? So here we would say, yes, it does violate. The majority criterion. Because the majority criterion would say that B should be the winner no matter how we calculate the election, because it won the majority number of votes. What would have had to be here for it to not violate it would have had to be that B was also the border method. Does that make sense? In that case, it would say, no, it does not violate. So think about that and see if we have any questions. So if not, let's do apportionment. Whenever we learn apportionment in our class, we had two different methods, the Jefferson and the Huntington Hill. Now, just like on the chapter exam from this section, do y'all remember that in the exam there was that picture of the instructions of how to do the Jefferson, how to do the Huntington Hill? That'll be provided on the final as well, near these problems. So I'll give everybody a moment to fill in these remaining cells of the table. Now we know that MQ is always the population of that category divided by the modified divisor MD, which was given to us. So here I would take 300 divided by 45. Now it did say round to 2 decimal places, so I see 6.66. The way to know how to round is you go to the second decimal place, and then you look, is the number to the right of it, this 6, if it's 5 or greater, this number rounds up to 7. If it's less than 5, it stays at 6, but since it's followed by a 6, that means I round up. So I would round it to 6.67. Similarly, I take the population of English, 250, divided by 45. Give everybody a moment to think about how you would round that to 2 decimal places. So we find the second decimal place 5. We know that's either going to stay a 5 or round up, all based on the behavior of the next number. The next number is 5, so if it's 5 or greater, you round up, so that should be 5.56. 120 divided by 45. Think about how you'd round that to 2 decimal places. And here we do want to be precise and follow the rounding rules. So this 6 will either stay at 6 or round up to 7 based on this behavior. It is 5 or greater, so it rounds up. And then 200 divided by 45 is 4.44. This will stay a 4 or go up to a 5, but the number after it is 4, less than 5, it just stays the same. Now for the Jefferson method, the rounding rule for the Jefferson method is no matter what the MQ is, it just ends up being the integer portion of the number. So it's as if you could imagine covering up the decimal part and you're just left with 6, 5, 2, and 4. So you just pretty much forget about the decimal no matter what it is, we just keep the integer part. And that's how we'll distribute these seeds. Any questions that we could answer for this Jefferson method? So if not, if y'all would do the next problem, which deals with the Huntington Hill. Remember, the main difference here is we still do MQ like you did before, take the population divided by MD, but then you have to calculate this new thing, square root of AB, and then based on these two, you'll figure out how to round this. Give everybody a moment to at least find the MQ on their own. y'all agree with these MQ values when rounded? Okay, good. Now let's recall how to find the square root of AB if you don't remember already. We'll do it for one and then I'll give y'all time to attempt the next two. The way to think about A is always the integer part of the MQ we're dealing with. So right now I'm going to try to find the square root of AB for this row. So I look at my MQ and I just take the integer part, the part to the left of the decimal. So A is 5. B is guaranteed to be whatever A is plus 1. So in this case, it's 6. So what I should type into my calculator is the square root of 5 times 6, which is the square root of 30. I'll find that in my calculator and round to 2 decimal places. So 4.47. Now I look to the right, it's a number greater than 5, so this rounds up to 8. 5.48. And then how do we deal with this? The idea is this square root of AB is like a benchmark to see whether we should round up or down. So think about our MQ here. If the MQ is larger than the square root of AB, it rounds up to the next integer. But if the MQ is smaller than the square root of AB, if it can't kind of make it over the square root of AB, then we round down. So considering these, how are MQ and this square root of AB related? Do we agree in this case 5.83 is larger than 5.48? So should we round it to 5 or to 6? 6, perfect, because it goes up. So since this number is larger than this number, it kind of overcomes the limit. This is kind of like the testing. If you can be larger than this number, you can round up. But if you're not larger than this number, you have to round down. So 5.83 is larger than 5.48. So we'll round up to 6. Now, if everybody would take a moment to do a similar calculation for our next two values for the biology and the mathematics. Remember, you have to find your new A, your new B, calculate that number, and then see how the MQ relates to that. So for this next one, the integer part is 4, so A is 4. B is always one more than that, so B is 5. So we have 4 times 5 and then the square root. In our calculator, the square root of 20 is 4.47 when rounded to 2 decimal places. And now we have to ask ourselves, does this, if it is larger than this number, I can round up to 5. But if it's smaller, I have to stay at 4. So just by a show of hands, which do we think it is, 4 or 5? Correct, everyone so far? Good. 4.17 is smaller than the square root of AB, so here our MQ doesn't overcome the square root of AB. So since it's smaller, we're going to round down to 4. I'll give everybody a moment to calculate the last one if we haven't done so already. Do we agree A would be 2, which means B would be 3? So we're looking at the square root of 2 times 3, or the square root of 6. And did y'all get 2. Now let's see, 4. We want to round the second decimal place. We look to the right, it's definitely larger than 5. So to get 2.45. Okay, now let's compare. Is our MQ value larger than this value? Yes, so in our mind, we're visualizing the MQ overcame the square root of AB, and we know if we get to be a larger value, we round the MQ up. So we think, should we round this to 2 or to 3? Do we agree? 3.